Hi everyone again. So this is Diego from Warsibu. I'm the CTO and I'm the lead developer of the Convector framework. Uh, so in this occasion, I will just give you a quick introduction to what Convector does. Convector is an open source framework to create smart contract systems. So actually it's evolving on a Convector suite, which is a set of tools. Convector smart contract is just one of the tools. Where we're adding continuously more and more tools. Uh, we're going to be talking a little bit about Hori, a new tool from our developers as well. Uh, and yeah, just a quick overview about the Convector ecosystem and what you can achieve using Convector. So I would just share my screen now and I'll start the presentation so you can guys can leave the comments on the YouTube video, and I will keep looking at the comments constantly. So if you have any questions, just put it in there, and I will answer properly. So yeah, that's it. Let's start the presentation now. So the talk will be about Convector Suite tools for smart contract developers. Um, First of all, a little bit of introduction about about myself. So I say I'm Diego Barahona, and I'm currently the CTO of the company and the lead developer of Convector and other tools. And about a little bit about Warsibu, what we do is we focus mostly on blockchain tools for the enterprise. Convector just happens to be an open source that we released like on July last year. Over all this time, we have got like 30,000 downloads already on npm, and we got a community on Discord. So the community is growing constantly. We got some people making pull requests and adding some new features to the framework. So I'll actually invite all of the watchers to join our community after the call. I think the link will be on the description notes on the video. Convector is mostly formed by the convectors and smart contracts, as I told you. This is a framework to create smart contracts projects easily without having to know too much about the details of the blockchain implementation too much. It's actually agnostic. It's an agnostic framework, so you can develop smart contracts for multiple blockchains with Convector. Right now, we only have official support for Hyperledger Fabric, but actually there's no limitation in the framework on what blockchain technology you can support. We also have Hurley, which is a development environment tool. With Hurley, you can just create Hyperledger Fabric networks easily without having to do a lot of research and a lot of investing a lot of time on figuring out how to do things properly. And with Hurley, it's just a command line utility that you can start up blockchain networks with just single commands, and you can add multiple users, multiple organizations, and multiple channels. I'll talk a little bit more about that, about Hurley and Convector during the presentation. We also have two other projects. One's called Forma. Forma is an autonomous blockchain infrastructure. It's just a fancy name to say that you can create any blockchain network production ready with just a few clicks, and there's nothing to worry about that. The configuration, Forma accepts contracts so you can deploy them right away on the infrastructure on whatever cloud you need. So we basically install the blockchain networks in each participant's cloud provider. And we also have Telus, which is a transaction designer. It's just a graphic interface to design. It's more like a smart contract designer, where you just drag and drop components and you can generate some validations, and you can generate some rules for your smart contracts. Telos is actually a software created using Convector. The smart contracts of Telos are made using Convector, and we deploy Telos using Forma. So it's more like our show product on how to use Convector and how to use Forma. So to get a little bit on topic of the talk today, I'll be talking mostly about blockchain. So I'll first give a little bit of introduction about the main topics that we're going to talk right now. So blockchain for software developers, and when you say this phrase, there's some confusion in the field right now, because there's actually two roles in the blockchain development industry, and one is the one that develops one blockchain technology. For example, the guys that create Ethereum, the guys that create Fabric, the guys that create Burrow, all are blockchain technologies, and those are blockchain developers. But we focus mostly on the ones that develop for a blockchain. Those are called smart contract developers. So smart contract developers, if you think this on perspective on an analogy that you already know, for example, databases, there is the guys that create database engines like MySQL or Oracle, and there is the guys that create or develop programs that interact with those database engines. Those are the database developers, you can say. So in this case, we're going to focus mostly on smart contract developers, since the smart Convector, what it does is generate smart contract applications, and we don't care too much about the blockchain technology. We just care most about the smart contract application layer that interacts with the programs. So a little bit of introduction about blockchain. So just to give an example, blockchain is no more than a data layer, where a distributed data layer actually, where you have multiple organizations. Each of these squares is an organization, A, B, C, D, and E, and F, where they're all connected to each other. So they all share the same information, and nobody owns a piece of data. So on this example, this blockchain organization has a data type with the following information. They have a product with an owner and a weight for this product, and they all start with this information. So what you can see in here is I put the data in the center of this graphic, is because no one actually owns this piece of data. So all the organizations have their own infrastructure, and they all are hosting this data on their own infrastructure. So whenever one of the organizations send, for example, this organization A is sending a transfer, is invocation a transfer method, and it's passing a parameter, the participant B. So this will update the record properly for all of the organizations. So even though the transactions is between A and B, since they are all connected in a single blockchain, they are all holding this information, right? So this is mostly what blockchain does. Whenever someone transfers, it generates a new set of data, and it's going to be stuck in the data, just like this. This you can think of these squares like the blocks in the blockchain, where they are stuck one upon each other. So the data is actually not modified directly. What it generates is a new version every time you generate a transaction. It generates a new version. If you need to go back in time, like for example to here, you can just go and do it, and the record will be still there, and you can inspect what the data look at that point in time without any problems. And the good thing is that since this is distributed to all the participants and all the organizations, they have to keep the data correctly. They cannot modify it, because if, for example, the participant C modifies the data for itself or in its own database, the rest of the organization will still have the correct data. So what will happen in this scenario is that the network will reject the participant C because participant C doesn't have the right information or is trying to cheat the network. So based on this explanation, I can prove you that each organization holds its own infrastructure and its data records, but you don't have, as an organization, you don't have to trust on the records and on the hardware of another company. You can trust your own infrastructure and that no one has updated the records by altering them. You can see also that there is no tangible official version of the data. It's just a virtual agreement from the majority. So this chunk of data that I put in the center of this graph it doesn't live on a physical place. I mean, there is no official version for this set of data. Each of the organizations has a copy of this data, and the official version of the blockchain data is just an agreement of the majority of what the majority of the organization has. So we trust that if, as I told you before, if organization C tries to alter this data, although they can do it because they own data infrastructure and they can alter the information that they are recording in this infrastructure, the rest of the network won't be affected by C changes. So that's a good thing about blockchain. That's why we trust on blockchain. And the third thing that you can conclude is that a blockchain is used as a data layer. It's just that. It's just like an extra database on your application that you use when you have to replicate data between multiple organizations and have to trust these organizations. Or actually, you don't have to trust these organizations. You want to trust your own data. So, let's see. Okay. Just to give you a little quick introduction to smart contracts as well. Smart contracts is just a piece of code that you put on each of these organizations running the blockchain. For example, I have organization A, B, and C, and I want to send a transaction that says that I want to transfer something to organization B. So each of these organizations, what is going to happen is they're going to check their own blockchain data that they have in their own servers, and they will compare and run a set of logic that is the smart contract. So if the smart contracts return, they will return something. They will either return everything is good, or they will return something has failed. If what they return doesn't match with everyone, the transaction is rejected. And this is partially true on Fabric, which is the blockchain technology that we use most. We use the most on Convector. You can define actually the policies on what you should accept or not. You can say that you need to, for all the organizations to be agreed on something, or you can say, okay, like let's say 30% or 60% agrees on something. You can pretty much define that. But for the sake of this example, let's assume that all of the three organizations has to be agreed on a transaction. And if organization C says, no, this transaction is not valid, then the transactions will be rejected. The case is different if I do the transaction and all the organizations agree that these transactions that I'm sending is actually pretty valid with the data records that they have stored in the blockchain. So this will produce, if everyone agrees, this will produce a new block that will end up being added to the blockchain. Yeah. So just a summary of what I just say. Let's think that the smart contract developer has to understand a little bit about the application business logic. So the smart contract developer doesn't focus on the blockchain technology per se. They focus on the application logic and how they can make the blockchain technology actually work for the use case. So this is a pretty valid point that you have to keep in mind if you want to be a blockchain developer and a smart contract developer, sorry. They need to comprehend the limitations of the running environment. So running a smart contract in a blockchain is pretty much just like running any other piece of code that you're used to run on your backend, for example. But it has some certain limitations. For example, since the transaction, I will go back to this slide. Since the transactions has to be executed on each of the organization's hardware infrastructure, they have to be deterministic. So the result of the functions of the, or actually the result of the invocation of the code has to be very precise. And it cannot, for example, generate random numbers. So imagine what will happen if you send a transaction to this organization and it generates a random number, and in here will generate another random number, and here will generate another random number. They are probably going to be different. And since the data cannot be different, they have to agree on the result of this execution. The transactions will be denied. So there's certain limitations that the smart contract developers has to keep in mind of those limitations when they're designing the smart contracts. The other responsibility of the smart contract developers is to integrate the contracts with the rest of the applications. So being a smart contract developers is not just developing a smart contract, because well, that's a simply first step on the process. But most probably you have to integrate this contract with an existing application, or a new application, doesn't matter, but an application that will interact with the real world. This is an IoT trying to send transactions to a blockchain, or a backend application, or a mobile phone, or a browser trying to interact with the blockchain. They have to be some integrations between the smart contracts and the application per se. So all this is what Convector helps you figuring out and make you like your life easier when you try to develop smart contracts. That's actually why we say Convector is a smart contract framework system. So it's not just a smart contract piece; it's just the entire stack that we can help you use. So to start a little bit on the matter, Convector is pretty much based on a model controller pattern. This is because it's one of the most popular patterns on the software development industry. If you have made backend any other application before, you are most probably familiar with this approach. You have just one model, and a model describes the data, and you have a controller, and this controller describes the logic that happens with these models, right? So Convector models are simply pretty simple. Convector is based on JavaScript, most specifically on TypeScript, which is a superset language of JavaScript. You can write a JavaScript valid language on here, but TypeScript adds some types on top of the JavaScript logic, so you can feel like more robust and comfortable about the data types that you're trying to manipulate. Even though if you haven't done any TypeScript ever before, or even if you don't ever have done JavaScript before, you can pretty much understand what's going on in this file, in this Convector model. So basically, you have a class of named product. This class extends the Convector model, and it's pretty much just a list of describing the properties of this model. So a product may have a type, may have a name, an owner, the owner of the product, and a weight of the product. And this is actually the example that I was showing you on the first blockchain example, on the card and the organizations transferring the products. This is actually the model describing that. So it's basically describing properties and putting some annotations, some decorators on top of it. So these decorators are part of the framework, are part of the Convector framework. They basically help you out Don't worry about data validations. Don't worry about some naive logic that you have to put or build otherwise on your own code. And what this helps you is to abstract a lot of the logic that you put on your contracts. Most of the time, you end up, when you write a plain contract without Convector, you will find yourself like making sure that the data type that you're getting is a string and it accomplishes a certain format. Convector helps you figure out this without having to do anything much. Just put the decorator in there and you're good to go. On the other hand, we have a product controller. This one extends the Convector controller. This pretty much describes two functions, a function named create and a function named transfer. Each of them, for example, a create function has a param. Its parameter is called product, like product. And Convector has this decorator called param that it essentially lets you parse whatever the information they send you as this parameter and to parse it into an actual model. So if you put a param, you pass a model in here, which is actually this model that we were describing in here. It will try to parse whatever they send you on this parameter and shape it in the way of this model, making sure the validations are being kept and all the required fields and etc. So you can pretty much be safe on here. You can rely that what you will get is a valid product inside your chain code. So to describe a little bit of the logic that we're getting here, we're trying to create a new product, right? You get the product as a parameter, and then you say you assign product that owner is equal to this that sender. What this logic is doing is I'm setting out the property owner of this product to be this dot sender, and this dot sender is a property of Convector controller. This property has the unique identifier of the person or the application invoking this smart contract function. So you can be sure that whoever is calling product controller.create is going to be the owner of this product that they are creating. This is pretty much the logic that we're describing here. This sender is a unique identifier, so you can use it like to prove authority of ownership. You can use it to authenticate a user, for example, and you will see how in the transfer example, actually. So the transfer example is getting two arguments. In this case, is getting a parameter of string. So this, I'll explain a little bit this. Jub.string. Jub is an NPM JavaScript library that is used for data validations. We use that so you can make really expressive validations inside models and inside controllers. So Jub has a lot of methods that you can use. For example, if you want a string to be of a certain length or a string that accomplishes a certain format using a regex, you can do so by passing all the information to Jub. Jub is an open source library, so you can find all the documentation in GitHub. And it already comes with when you install Convector, so it's good to use. Back to the example, you have two arguments in here. You have an ID of type string. You have a new owner of type string. And what you will do with those two parameters is, okay, so what we want to do is transfer a product. So the first thing to do is to get the product that we want to transfer. So we do product get one, we pass the ID, and we get the product back. And since we are transferring the product, we want to make sure that whoever is invoking the transfer function, they are the actually owner of this product before. So we make a comparison between the product that owner, which was the one that created it, against this that sender. And if they are not the equal, if they're not the same person or the same authority making this transaction, we simply throw an error, and that's it. This is how we reject a transaction in Convector. You just throw an error, and these transactions would ever occur. If this condition never happens, it means that the product's owner is actually the sender, the one that is invoking this transaction. So they have permissions to transfer the product. So we basically just assign the product's owner to the new owner, which has the parameter as a second argument. This way is how we just transfer this product, and we call product.save, and basically that's it. With this tiny piece of logic, we executed a transaction that is transferring the product ownership, and now the old owner can no longer transfer the product anymore, since it won't be the product owner anymore. So I'll check a little bit on the YouTube. There's the questions. No questions. Okay, yeah. Just remember, you can just put any questions that you have in the chat, and I'll try to answer it for you right away. Okay. Just to explain a little bit more on detail about the models and controllers and what the decorators are, we have a pretty few decorators, I think, right now. So every model has two required properties. They need to have a type, because when Convector stores the data on the blockchain, it will store it as a plain JSON file. So we don't store any actually typing information about what the model was. So that's why the type is required. If we need to set up a single type for every Convector model, so we can keep track of that. And you can put in here whatever you need to do, whatever you need it to be. It can be, for example, in this case, just an example of a class name describing a domain class name, describing the ID, and you need to have an ID. So those are the two most basic properties of a model, and you have to respect them. This ID has to be unique. If you put another ID, you're basically creating a new different model, right? And the old ID will be kept in the ledger. Just to continue with this example, we have two decorators in here. We have the read-only decorators that essentially it says that this property can be assigned once. It's either it can be either assigned like in here in code, for example, and then it cannot be updated anymore, or you can leave it open, like in this case, like the ID, and after you assign the ID once, it cannot be updated anymore. So those are the uses for the read-only property. It's pretty useful for example, when you have a property, for example, I don't know, the ID of a car or the SKU of a product or things like that you wouldn't want this property to ever change. So you just put the flag read-only, and it will respect it. Will make sure it never change. You can have also a required field. The required just makes sure that this property has a value before saving it into the ledger. So you can have operations where you are building a model and you still don't want to give a value to a property, but Convector will just make sure that there is a value before saving it to the ledger. So it's pretty useful. There is another decorator called validate, where you can pass a JUP schema like using here, or you can pass a model. So a model is actually a valid schema, a valid JUP schema. So you can pass any of those as valid parameters to validate. And what it would do is when you're constructing a model, it will make sure that whatever you are assigning to this property, it validates with what you put in here. So as I told you, if you put, for example, some complex validations in UP, for example, UP, that string, that max length 6, it will make sure that the string that you're trying to assign doesn't have a length of more than 6. Another decorator that we have is the default value, and what it does is when you're when you're trying to save a model and it doesn't find any value for this property, it will just assign whatever you need, whatever you have in the default. This is it's important to make sure that this is a persistent model, a persistent time. So whenever you are trying to build a new model just to work and fill it with data, you still don't have the default. You only have the default only when you're calling the .save property and saving this to the ledger. Another concept that I didn't tell you is how Convector is actually achieved to be generic and doesn't depend on any blockchain technology in specific is because we have these abstract concepts called the controller and the model, but we also have some helpers for the controllers and models to bring the specification of each of the blockchain technologies that we use. On models, this ledger is called storage. So the way that you configure new storage is, for example, here you set the base storage current to whatever object you need. In this case, we have a CouchDB storage, for example. The CouchDB storage is used in Hyperledger Fabric to query the CouchDB instance the Fabric creates per each node in the network. So it basically Fabric creates this CouchDB as a replicating the actual state of the ledger alongside with the peer. So even though you have all the information in the peer, in the node of the blockchain, querying the information of this peer can be expensive. For example, if you have like a rich query, or you have to make a join of multiple data, querying this in blockchain means that you have to go block by block, like in the example. Like in the example in here, it has to go block by block by block by block, looking for the data that you're trying to look. Having a CouchDB alongside each of the peers make sure that you can make rich queries to the ledger without having to be very expensive on that sense, because you only have the last state of this blockchain. So Convector makes use of this ledger, of this CouchDB, sorry, by using a new storage. So we have actually multiple storage. We have this CouchDB storage. We have a Fabric storage. It's called actually Stub storage. That's the one that we use when you're running inside the Hyperledger Fabric network in a smart contract, in a chain code. But for multiple purposes, for example, for backend querying, you can set up the CouchDB storage. Each of the storage ledger has its own configuration. For example, this one that is for CouchDB, you need to pass the host, the protocol import, and the database that you want to read. Another storage can have another configuration. Just to give you an example, most recently, I added support for Convector to be run on the browser, just without any blockchain behind it. It's just like a demo purposes. I created a local storage, for example, where it is storing and it is querying all the information in the local storage, in the browser's local storage, for example. So Convector is flexible enough that you can just swap any of these layers, and you can still have the controller in the model without it knowing where it's going to be executed. It can be executed on a server, on the browser, on a blockchain. It doesn't matter. So all it's do is to send all the information to this ledgers, the storage, for example. So that was for the models. They're pretty simple. It's just a couple of decorators and a couple of logic in there. Now we're going to jump to controllers. Give me a second to check. Right. So we have the controllers. And the controllers, this is described in the sender property that I mentioned before. This is a unique identifier. It's actually a fingerprint. Technically, it's a fingerprint of the certificate of the entity sending the transaction to the blockchain. So, on blockchain, every single participant has a private key, and this private key has a public certificate corresponding to each private key. What the content of this sender is actually the certificate, the fingerprint of that certificate. So it is assured to be unique for each participant, and you can trust that mostly as the identification of the person or the program sending a transaction to the network. As I mentioned before, the functions in controller has to be deterministic. This is not a limitation of Convector per se. This is a limitation of blockchain development, of a smart contract development in general. So you can, for example, assign values to models based on parameters, on inputs. For example, weight params is just an input that got me to the function. What you cannot do is generate values using, for example, not deterministic methods. For example, math.random. This will generate a random number, and since the chain code is run on multiple organizations at a time, it will generate different random numbers for each of them, and it will cause a problems. Another thing that you cannot use is, for example, day.now, because that even though that you send the transaction at the same time to each of the organizations, they might be busy processing another request, another transaction at a time. So the exact time of execution won't be the exact same on each of the organizations. Who's asking on the YouTube? Who's streaming? Yeah, this is Diego. One that is streaming. Okay. On the controllers, you can pretty much use any npm module that you have viable. You just have to stick to the limitations that I described before. So, for example, if you trying to import a new library that uses random numbers or that uses dates, it cannot be, that it cannot be used because it will generate problems when you send transactions to the network. Another limitation is that you shouldn't be relying. Actually, you shouldn't be have access to the network or to the file system or to actually any other method to read information from the outside world. All you can read is information from the same blockchain. For example, querying the states, the models that you have saved previously, or using parameters coming from the functions. But you cannot access the network or the file system. And there's a valid reason because of this, is since network is not that deterministic operation, when you make a request, it can fail. For example, if the service that you're trying to reach is not stable or is having an outage or something, it can give you a 404, and that won't be deterministic. And you're trying to input outside world information to the blockchain. And even though if you guarantee that your organization running your smart contract will have valid access to this HTTP or TCP connection, another organization running the smart contract might have some problems accessing this because of a VPN or something like that. So you cannot rely on network access at all. The same thing with file system. A file system might be present on your container for the blockchain, but it might not be present on another's container. So to avoid any problems on having like transactions conflicts, you should avoid any kind of external information getting into your smart contract execution logic. As I told you before, that models uses storage layers. controllers uses adapters. The adapters, the function of the adapters is, for example, when you invoke a new controller, or when you're trying to invoke a new function in your controller, the adapter makes sure that it will handle this request properly depending on the technology that you want to use. For example, in this case, we have a Fabric controller adapter. The Fabric controller adapter is used when you want to interact with Fabric networks. This controller adapter is using the Fabric SDK to communicate and send transactions to the Fabric network. It's not doing anything special behind that, but you can easily plug and play another different adapter in here that, for example, goes to I don't know, goes for Ethereum or go for another blockchain technology. We only right now have support, as I mentioned in the beginning, support for Hyperledger Fabric. So we officially only have this Fabric controller adapter as a blockchain technology. We do have some other adapters. For example, we have a mock adapter that you can use for unit testing. This adapter, instead of going to a blockchain, will just emulate a blockchain in Node.js. It emulates pretty well the transactions, and you can use it to prove that the controllers that you're writing make sense when you try to deploy this to Hyperledger Fabric. As well as with the storage layers, you can pass a specific configuration for each of the adapters. And you can even have multiple adapters in a single application. There's nothing stopping you from doing that. So just to give you an example, a couple of months ago, we needed an application that to store some information in Fabric, but at the same time to store the same information, well, some of the information in a MongoDB database. So what we did in that occasion was to create a MongoDB adapter, and we were invoking the controllers using both of the adapters. So even though the controller was the same logic, it has the same logic, the output and the logic for this transaction some of them route to the Fabric blockchain, and some of it will go to a MongoDB database that we have outside. So this adapters is what makes Convector really flexible and really cool with what you need to do. If you don't like for example, what we have in the official Fabric controller adapter and the ways that we handle transactions and things like that, you can pretty much use or create your own Fabric adapter if you need to. If there is any edge case or a specific case that we don't support on the official one. So it's pretty cool, and we actually expect the community to create more adapters and more storage layers depending on their use, and hopefully publish them on NPM so we can all reuse them properly. Controllers, when you need to send a transaction, this is what it looks beautiful in Convector. Is all you need to do is say the name of the controller, product controller, the instance that you have made before, and call the functions that you describe in your controller. So just by doing product controller.create, and you pass a new model with all the information that it needs, the ID, the name, and the weight. This is pretty much going to send out transactions. And since you see a weight in here, wait's a JavaScript token that tells JavaScript to wait for this transaction, these assigned operations to be complete. So after this line, you can make sure that the transaction was performed properly. So it's pretty cool. If you grab this in a try-catch block and something fails in the transaction, you will get the error in the catch, for example. So this is pretty versatile. So that was mostly for the part of the Convector framework. Now I'm going to talk a little bit about the Convector CLI. We have a CLI. You can use, you can see pretty much in here generate new Convector projects without doing too much. All you need to do is npmi.g/convector CLI, It will install a global utility on your computer, and then you can just do conf new my chain. This is going to be the name of the project. Dash C token. This will create a controller name token, actually a chain code name token actually. And just by running those two commands, you will end up with a project looking like this. It will have all the files that you already need to interact with a blockchain application. It will create a token controller in the token model. And I'll actually run an example of this. New my project. And you can see, well, give us a couple of seconds. It will create a lot of files. Well, not a lot of files. And if I open this, my project, I'll have an editor. This is slow because I'm screen sharing. Let's take a look. Okay. So here you have packages, and you have my project that .cc is this Convector controller, Convector chain code actually. And here you have my project controller, which comes with a pretty basic controller, with a create function, and receiving as a parameter my project model. My project model, you can find that in here. Oh, it's a little bit slow, my computer right now. So you can have my controller, my project in here. This is a model, sense Convector model. It has a pretty basic properties, type, name, created and modified. So you can just start creating code from this right away without having to do too much. It says it doesn't find the modules in here. It's because you have to come and run npm in here. I won't do that because since I'm screen sharing right now, my computer is pretty slow. Actually, I will just run it in the background probably at the end of it. Whoa, it's done. Oh, no, my project, npmi. Okay. Yeah, I'll leave this running and I'll come back in a few minutes. But yeah, I just wanted to show you and encourage you to try this out. The Convector CLI is pretty easy to use, and you can just start any Convector project in seconds instead of going through a tutorial and follow everything. Although we have some pretty good tutorials and some good videos on YouTube on this channel. If you want to, you can go and check the videos, the video library that we have. Walter, which is my partner, has created some good tutorials about how to use Convector and explain some of the terms more in depth. We also have this tool called Horley. Horley, what it does is create new fabric networks, fabric development networks. Because creating a new network sometimes is pretty complex. You have to take a look at a lot of the containers and Docker stuff and configure variables and a lot of things that you don't really want to know or do by yourself. So if just by installing it, same as Convector CLI's name, war cvu/Horley, and you execute horror new, it will go through a lot of steps, and at the end, it will end up with something like this, saying that the network has been succeed. You will have all the crypto material for this Hyperledger network in this path. And well, the basic network that it creates, it has two organizations, organization 1 and 2, and it will have a user 1 for each of those organizations, and it will have one channel. But this can all be controlled by input parameters in the whole new. You can say, I want a new blockchain network with 5 users and 3 organizations, and it will create so. It's really powerful, and we use it. It actually comes included in the Convector CLI project. You can take a look at the package JSON. It's already here. Let's see Harley. And actually, scripts to start the network, they are actually called new already. So if you use Convector CLI, you're already using Harley. Let's take a look at that. It's really cool. Let's see. I have some architectural designs just to give you an idea of what you can achieve using Convector or how you use Convector in real life application. So you will most probably have a blockchain since you're using Convector. Most probably you have a blockchain somewhere, and you have a backend application, and probably you have a front end application or a mobile API or something like that. And you basically create the controllers and models once, and you will you will end up using those controllers and models everywhere. So you have the controller model, and you use those in the blockchain, right? That's you package that in a chain code, and you upload the chain code to a blockchain and install it in all the organizations, and cool. It is running there. And the way that you invoke those controllers and models is by using the same controllers and models code that you have in your backend application. You just put a storage layer in here and the fabric adapter in the controller, so it can talk to the corresponding blockchain network and some transactions. Do that. The same way with the front end, you can have a storage and an adapter calling or invoking the Convector functions back to your backend API, for example. We most recently released the Convector REST API, which is a tool contributed by the community. It's from a member called Luca. Thanks, Luca, by the way, if you're looking. So he generated a Convector REST API. What it does is with decorators, you put those decorators in your controller, and this creates a backend application for you without you having to do actually anything on the backend. So you can, if you're a front-end developer, for example, you can use Convector and use the Convector REST API, and you don't have to worry at all about your backend application. And you just develop the storage and the controller, or the models and controllers and the adapter, sorry, the storage and adapter. So your front-end application can talk with your backend application, and your backend application will talk with the blockchain. So this is pretty much the flow. As the same as with any other backend application, you can still in your backend consume any third-party APIs or any other external database that you have for your use case. Using Convector or doing a blockchain application doesn't limit you on what you have to do or what you can do on your backend application. So this is pretty much what it looks like on real life. And the architectural workflow for multiple organizations is there's probably going to be two or more organizations wanting to write into a single blockchain. Both those organizations are going to be still talking to third-party APIs or have multiple clients interfacing and using this backend application as an interface to talk with the blockchain. They can have its own database if they need to, and et cetera, et cetera. So doing a blockchain application with Convector, or actually a blockchain application in general, doesn't limit you on the technologies that you can still use, consume. You can still have third-party APIs or external databases, or etc. What you need. Blockchain is just the point where all the information that you want to share is going to be stored, but it's nothing more like that. And with this, I finished the presentation. I do have some demo and some surprises in this webinar. I have something that I have not shown to the world already. So as I mentioned in the video, we added browser support in the last 2 weeks to Convector. We haven't made the release of this yet. It's actually in a release candidate right now. So if you are interested in testing the browser features, just ping me directly on Discord, and I can give you access to that. Or the code is actually all in GitHub, so you can use it right away. But with browser support, we have support for this platform called StackBlitz. StackBlitz is it's just like a VS Code embedded in your browser, so you can make examples. You can make Angular applications or React applications in here, and now you can do Convector applications as well, and you can even mix them with our technology. So for example, I have one Convector application logic running here. I have a user controller. The user controller sends a Convector controller the same. And it has a register function. It receives a user. And here I'm making a query just to make sure that the register, that the user they're trying to register with this ID doesn't exist already on the ledger. So you can test that like that in here. And I'm setting user that allow identities to be an array containing this.sender. So the logic for me on this model, I should show you the model first. The user model actually just have the type, the name, and allow identities, which is an array. The idea here is that you can assign multiple identities to a single user, so multiple outside users, outside from the network, from the blockchain, sorry, can act as this user inside the blockchain. So you can do pretty complex things like that in Convector. So that's how you do it here. And in the controller, you just assign the initial, the one that registered, you put that as the first index in the array. I have this other method called rename. It will receive an ID and a new name for the user. So what I do again is querying the user. So I get the user reference with the ID that was given me to me in the parameters. I make sure this ID exists already. If not, I throw an error. And I check that the user allow identities include the one that is sending this transaction. That's actually how I check they have access to this. And at the end, I just end up with a user.update, and I pass the properties that I want to update its name. So this is a syntax similar to what I can do using user.name is equal to name and await user.save. It'll be the same to do this too. So user.update is just a shortcut to avoid having to do so. And you can see on my right side, I have a live preview of the code that I'm writing. It's pretty cool. It's actually, you can have multiple things running here. I'll actually put this on the comments in the YouTube video. So you can play with it a little bit if you want. So yeah, this is pretty much the logic in here. I will show you also an example of Convector running with Angular. So I have in StackBlitz an application running with Angular. It's just a simple HTML, a header, a form to register users, and a list of users. And I already did some tests before the video, so I'm getting some data here. This is actually using the check. Yeah. The Convector storage, local storage. So it is actually storing all the information that I'm using here in my local storage. So if I go in, take a look, inspect the element in here, go to application, check local storage. I get some of the properties in here, describing all the information. For example, this is actually what Convector will store even on here, on this using those local storage, or on a blockchain using a Fabric compatible storage layer, for example. So, but yeah, to explain the example, I have the same user controller, user model that I showed you before. I also have a balances property. It's a number. And in the controller, when I'm registering the user, I'm setting up the balances to be 1,000. And then I have a transfer method that will transfer money from one user to another. So I get a from user to a user and the amount that wants to be transferred. What I do is, well, I get both of those, of both of the users, and I make sure both of them exist. And then I check the identity of the from user to be this.sender. So this way I make sure that only the user that has the right property, the right sender, the right identity, can transfer from money from their own, right? Uh, Another check I do is that the from user has enough funds to make a transfer. This is something very important to check. You don't want them to transfer more than what they have in their balance. And at the end, I just update the balances. So I discounted the amount. I add the amount to the new user and click on save. So you can see this working. If I try to transfer Walter's money to my own, this is something I love to do: transfer Walter's money to my own. And I put a password in here. I register them with a certain password. So if I click in here, I get a real time because I'm using Angular, and I get the transfer of the money here. If I try to do the same, I type in the ground password for it. For example, I want to withdraw another 500, and I try something, an incorrect password. I will get an error in here. You can see permission denied. Only the owner can transfer to another user. This is because my identity was not the correct one. So I'm getting this error. So it's cool. And yeah, hope you like the workshop so far. I think the time run already, 7:06 in here. So yeah, if you have any questions, I see there's no questions in the YouTube video. But if you have any questions after looking this video, or if you're looking the video as a record on YouTube after we finish this recording, you can reach out to us in Discord and ask us anything. Or the community is pretty active, so you can write any questions you have in there, and we'll probably come back to you soon. And yeah, I think that's it from my side. I will give you a couple of minutes just because YouTube has a latency between what I'm saying right now and what is getting into the comments. So if everyone has any question right now, you can write it right away, or otherwise I'll finish the streaming in a couple of minutes. But yeah, thank you very much for attending. Actually, it's something I forgot. I left the CLI project installing, and this is the output of the installation. It's a lot of things that I do. But yeah, I now should have all these typing errors that are gone. So cool. This is a Convector project up and running already. And we even generated with a couple of unit tests. So here we're using the Convector adapter map, the one that I was describing you before. This one emulates a blockchain network inside Node.js, so you can make your unit tests pretty quick without having to send transactions and wait for confirmations and things like that. Yeah, I think this is everything from me. Thank you very much for attending, and have a good day.